So in this question, what we have to do, we just have to find what is the distance between point M and point A. What is the distance from point M to the point A? So how will I find it? I will apply the principle of moments for any system in equilibrium. So any mechanical system in equilibrium requires that total sum of the clockwise moments, like turning effects acting on a system, has to equal to total anti-clockwise or total anti-clockwise turning effects in given mechanical system. So what we have here, we have a wheelbarrow here, and we said that the weight of this wheelbarrow is equal to 80 Newton, and M is the center of mass of this wheelbarrow. So M is the center of mass. So it means weight, which is known as the gravitation force, will be acting from the point M. And we also note that there will be upward normal force from the center, which is right above the pivot to the wheelbarrow. Okay, so let's consider 20 Newton is going to create clockwise moment. Weight is going to consider anti-clockwise moment. This force, upward normal force, is also going to create anti-clockwise moment. So if I apply this principle, m clockwise is equal to m anti-clockwise, I can easily find out what is the difference, what is the what is the distance from point A to the M, or otherwise from point M to the A. So let's write it down. So let's find out how much 20 Newton is creating as a anti-clockwise turning effect, or anti-clockwise, not anti-clockwise, clockwise turning effect. So how much effect does 20 Newton has on a pivot? So 20 Newton will create M 20 Newton is equal to 20 Newton times it is perpendicular distance from the pivot, which is going to be 1.5 Newton, and it's going to be 30 Newton times meter. So because this yellow force, which is upward normal force from the point A, is just right above the pivot, I'm just going to write its moment. I'm just going to write its moment, like moment of this F normal force from the point A is just equal to 60 Newton times meter. So you may ask me, why did I write it 60? Because I have a 20 here and I have an 80 here. So if this system in equilibrium, it means total force from downward has to be sum of the forces from upward direction. Okay, so if this is 80, if I subtract 20 from 80, I'll get 60. So their sum has to be 80 again. Then moment of this one also going to be, so I'm going to label them. So this one is a clockwise, this row will show only clockwise, and this row below is going to show anti-clockwise moments. So one of the anti-clockwise is going to be this yellow force, and second one, I'm going to write this here. I just have one clockwise and it's this. So second anti-clockwise is going to be, I'm going to write it with the red color. So moment of the weight is going to be 80 Newton times distance from point M to the A. Distance from point M to the A. So according to this information, if I use this information for solving the problem, okay, let me use white color. So if I use this information for solving the problem, I can easily get that M 20 Newton is equal to M FA plus M weight, because this is clockwise and this is the sum of anti-clockwise. Okay, so I can write 30 Newton times meter equals to 60 Newton times meter plus 80 Newton times dma. So I can write 80 Newton times dma is equal to negative 30. So because I'll use the model, I'm just going to write it 30, because if I put this over here, it's going to be negative, but I'm going to write it as a positive number because I'm just looking forward for finding this one. So it's equal to 30 Newton times meter. So dma is equal to 30 divided by 80. And this is going to give me 0.37, then 5. And if I round it up, it's going to be approximately 0.38. So it means dma is equal to 0.38 meter. And this is the solution.